This is the milling head on my Hobbymat 65, and I searched on the internet and could find almost no information on how to disassemble the unit and in particular how to remove the spindle. The head has a number of gears in it, which in this particular case they're not in too bad condition, but they are incredibly noisy and the speeds that are put out as a result of the gearing are not quite as flexible as they might be. So I'm going to replace the motor with a 24 volt 500 watt scooter motor, which I've used as a spindle motor and works very well and gives a nice range of speeds depending on the pulley setup of between 100 and 1500 RPM. The motor itself is capable of turning at up to 3000, but there's no need to have it running that fast. Now the milling head has got a spindle that is lowered as you push the lever down, and there's quite a strong spring that retracts it back up again. And the first thing I want to do is to remove the spindle right out. So this is the top of the spindle behind this casing here and the motor is to the side, and I'll leave all the gearing in place except the one gear at the top of the spindle shaft, and I'll replace it on the outside with a pulley belt and gear and pulleys between those two. I've done a similar arrangement on my large mill, and that works very well. So the first thing I had to do was to try and find out how to get the spindle out, and it is actually, I think, quite easy. So I'll open the case up and show you. Let me just zoom in a bit. All the screws are loose because I've had it apart. This is the arrangement for the handle, and there's a bar that goes, or a rod that goes across here, pin that goes across in that part, and I've taken that out already, and I've removed all the screws. And there's just a bronze bush inside here. Now this is the set of the gear ratios that are in here. Now this of course mustn't be run under power while changing gear. There are two levers on this side. That's currently set up for 900 RPM. Just turning the spindle from the bottom, and if I move this lever, you have to just joggle it around until it drops into the appropriate slot. That's 315 RPM. And both of those together, that's 560, and this one back to the top, that's 1600. Now, as I said, these gears are extremely noisy, and it would deafen me if I was working on it, so I'm very keen to replace these. As I say, I shall just take this one gear off the top here, which will isolate this spindle, and then put a pulley on the top, raise this up a little bit with the new motor, make sure that everybody can see the inside of here, and that's more or less in the condition it was when I bought it, and you can just see there that in the back there is the dog that engages on the underside here when you change gear. And there's a similar arrangement here where there's a dog that points downwards that engages there. As I say, all the gears work perfectly well, they're not damaged. They've had a little bit of wear but not a lot, so I don't suppose this mill's been used very much. And there's a very substantial spring on the downward movement. So I'll show you what I have in mind. And behind the back of here is where there's the the key for the keyway that stops this spindle twisting and limits the amount of movement. So if I just put this in here, I can move this to show you. As it goes down, that is the key in the keyway, and when it gets to the bottom it pushes out, when you undo it, this. Now if I push that up a little bit further, the gear behind the back, there's a gear here that works on the rack at the back of the spindle. That runs past the top, including this cover. So I'm quite happy that I should be able to run this a little bit past where it would normally be, and then it should be possible to drop the spindle right out. There's nothing holding it in at the top. I've taken the shaft, the threaded rod out, so that's out, and there's nothing to stop it just falling out then. So I think the next thing to do, it's quite a substantial bearing on the inner side there. I think it's not going to be a problem if I do it. The only other alternative way of dealing with this would be to put a spring clamp around the spring. So I think what I shall do is I'll screw a stud in here, make sure it's in reasonable distance, and then turn this round past the stud and then let it rest against there. Then I should be able to remove this without too much hassle. I don't need to take the keyway out because I shan't be taking, it should just drop straight past. So I think we'll try that first. The alternative is to take out the 3 screws in the bottom here and then drop this casting out, but that might disrupt the alignment. I'm keen to avoid that if I can. Okay, I'm ready to give this a try now. Let's hope we don't have a problem. What I will do is I'll pull this down to wind it up and then hook it up on the screw there when I'm far enough to be able to get this out. Hopefully it won't drop out. I've got a piece of wood here to catch it down at the bottom if it's a problem. And then I'll slacken the spring off afterwards so that it's not under quite so much tension. So let's hope this goes well. Oh, there she goes. There we are. I think I'll just put that in that point there. It's not under anywhere near as much tension as it was, and I just put that in there, so that should be perfectly safe like that. Right, there is the spindle now out. So that went as well as could be expected. And looking at the end, that must be the original bearings, the original grease in there. And I think I may well just simply take the whole thing to pieces if I can get it apart easily, clean everything up and re-grease it. But that's only if I can do it easily. I'm not going to spend hours and hours fighting with it. Absolutely mint condition. Not a mark on it anyway. When I got this, the motor here was seized with rust in the middle, so it obviously hadn't been used for a long time. And the splines are beautiful. So it's a question of how this all comes apart. I have to consult the manual and just see what to do next. Finally, I've got the spindle out from the mill, which I showed earlier, and I've now taken it all apart with a struggle. Some of these things were done up very tight indeed. The worst one was the nut that was here where this thread is. I had to literally cut it off because it was seized on there. I just couldn't shift it. And I also had to cut the bearings off at this end, and there's a pair of angular contact bearings sitting here, another bearing, plain one, that sits there, and then two bearings at the top, moves up and down, and this is secured in position by these bearings. And the two bearings here are held in place by the circlips in these two grooves. What I've done here is that I've added a section so that this will be in the same position as it should have been at the beginning, in here, and you can just see inside here the circlips that hold the bearings. So there's one in there and one in there, and this here with that slot was what took the fibre gear in that sort of position there. And what I shall be doing is putting this in its same original position location, but extending it upwards so that it sits a little bit proud of this. And I shall be machining the top of this down about 14 millimeters. And in this here I've reduced the wall thickness by half, which ideally prefer not to have to do, but I just hadn't any choice, and made up an extension piece, and this is in ER16, so it's really good hard steel. And I'll glue that in with Loctite, and I made sure to end the position here that the bearing sits in that position there, so the bearing isn't sitting where these steps are, it's sitting slightly behind it, so there's less force on it, and there's only the force of the pulley at the top, which is not anywhere near as much. And I still have to do a little bit of machining off here to make sure it's less than that diameter, so I can get the bearings on. The bearings on this are incredibly tightly on, and I haven't got a press, so it's a matter of finding bits of tubing and things that I can then knock them off with, and in this case pressing them back together, for example. That's not too difficult to do. If I might have to turn some bits of aluminium up and then press them into there, and then press the shaft in. This is what holds the whole assembly together. And there's quite an interesting way of nipping it up so that it tightens up. You tighten that screw and it squeezes that slit up. And you need those 2 pins to be able to turn this, because it's quite a lot of the thread here and it can get a really good grip of it. You can see there's a lot of thread. And this little ring here sits in there. So the 2 bearings go up against that, and the bearings have a spacer between them on the centre shaft. The other interesting thing is that on the back of this, you can just see it here, that is a rubber seal with a spring around it, like a typical car type oil seal, and it's in good condition, so I'm just going to leave it. Some of these bearings are quite difficult to get hold of. The angular contact bearings you can get, but some of them are fearsomely expensive. This particular one, the 6204, that was quite tricky to get hold of. It's just a straightforward ball race, and I wanted the bearing that goes in here and these 2 to have rubber seals on so that they're secured against debris getting in. This has got a seal on the bottom, so that's not a problem, and this one will act as a seal on the top here, so I'm happy that that will work out okay. So just a matter now of assembling it all and getting it back into the mill, and then I've got to figure out how to do the pulley will be fitted onto here. I don't yet know, I haven't decided whether to do it with a slot and put a keyway in. That's probably the neatest way of doing it. That stops it rotating that way around, and I have got just enough room to get another of these into the top here. So I think I'd probably go with the spring circlip. It's probably that's the easiest way of doing it. It's just a matter of making sure when I do it that that's tight and doesn't slop up and down. I'm now able to put this back together, as I managed to get a new nut which is slightly thinner than the previous one, but it should be fine. And I didn't show you previously, this is where I took the race off, and you can see I ground through almost but not quite right the way through, and then hitting it with a screwdriver on this section here, and it just goes bing and opens up, and then it slides off easily enough. So I did that with both of these inner ball races, and that enabled me to get them off the shaft here. But the real problem, as I explained before, was getting this nut off, which was really stuck on. And I won't show you because it looks horrible, but I made a bit of a mess of some of the threads on the other side. I feel embarrassed to show it. Right, so what I've got to do now, these are the replacement bearings, and they go with the thin side to in and the fat side to out. So if you think about it, if you press this on the outside, it won't come apart. If you press it this way, it'll fly apart. So if you put both of these this way around, it'll take a load from that direction or from that direction. And this has a 1mm spacer in between the two. And there's just a small gap between these when they're done like that. So I've got to fill these with the Isoflex, Kluber Isoflex NBU 15, which is excellent stuff. I've used it before. It's very expensive, but you get what you pay for. Right, I put this on the end of here ready so I don't forget it. Move it up a bit. I put this retainer on the inside, the one with the seal in, on the end ready. I've put some grease in here, so that's greased up, and then this bearing will go with the fat end, thin end on the inside, fat end up against there, and I'll probably, in fact I will assemble it separately from being on the bench. I won't show you it happening on the bench, and then when I've got all this assembled ready and greased up, I'll show you, and then we'll assemble it in there. And this is slightly tricky when it screws on, because you can't knock this in all the way because the threads get in the way, so you have to screw it in a little bit, and then knock it in a bit more, screw it in a bit more, and move this sort of up and down as you're screwing it. Move it up and down as you screw it in. So that's the next job, so I'll do that, and then there's one bearing that goes in to, if I can get it the right way around, into the top end. That's this bearing in here. That bearing goes in there. So that's the last thing to do once all the angular contact bearings are installed. So I think I'm in a position now to put it all together, so let's try and get that done. Right, I've assembled this so far. These are the two angular contact bearings. And I've tightened the nut up. I was able to do that with the pin spanner using the two pin holes there, and this, that was quite reasonably straightforward. I've tightened it up. What I would say for me is pretty tight, but nowhere near as tight I think as it was when I took it apart. Right, the next job is to assemble. Now I've got this assembled and this done up, and as I explained in the previous video, there's a gap here, and you have to put the pins in and use the pin spanner to tighten this locking collar down, and I need to get this bearing in now to check that the running fit is right. I'm pretty sure that's okay, but I just want to get this in and make sure it's stable. Right, I'll come back when I've got that in. Right, I've finished assembling this, and I've put this bearing in at the end, and I've tightened the little collar inside here with the two pins, the two dowel pins that go through here, and by twisting that with the dowel pins in, it seats that down a little bit further against the angular contact bearings, and I reached the point where it's not too tight and not too loose, so I think that's probably okay, but it will be easy enough to adjust it in the mill anyway without having to take it apart. So I can put this back in the mill now. And this is the top part of the bearing assembly, with the two ordinary deep groove ball races in the top here, and you can see that one there, and that's held in place with a collar that I've made that takes the place of the original fibre gear that I've taken out, so it's in exactly the same position that it was. And this is the extra section I've added on the top. I machined this down, as I said, 14mm, so the bearing lies just flush like it does there on top of this. So this is just simply a pulley that I made up of approximately the right size to give me 2:1 bearing ratio, and it's made out of an old pulley, which is one that's still got some threads on there, and I held it in place with a keyway and a circlip. And the motor I've made the pulley for that. And that's the pulley for the motor, and it takes the standard or belt that the mill came with and the lathe came with. And I mustn't forget to screw this little screw inside here. A little bit fiddly, you have to find the hole that, oh, it's there. One of these holes, that one. It's a single hole on its own. So I drop that in there and tighten that up. And that just locks it in place. Yes, that seems to rotate reasonably freely. Yep. This is actually rather stiff, even though I've altered things a little bit, eased things a little bit here and there. The reason for that is almost certainly that the bearings are not perfectly aligned, but there's nothing I can do about that. So I'll get all this assembled now, and I can try it out soon. And finally, this is it, reassembled back. All in one piece. I've got the spindle assembled and the motor on the top up here, and I'm just checking the bearings to see that the fit of the angular contact bearings in the bottom here are correct. What I've done is I've tilted the head through 45 degrees. I've left the motor on top and just been careful to tighten up the screw so that it doesn't slop around. And if I turn this, you can see the two larger holes on the bottom here, which are the ones that take these pins, the 6mm pins, and they go in there like that. And if you turn this towards me from the top here, that way, and the bottom that way, that tightens up the collar inside and reduces the amount of play in the bearings. If you turn it the opposite direction, it gets looser. And what I found is if I have it mounted like this, I can quickly put the motor on and check it, and what I'm looking for is it doesn't want to be too loose, otherwise there's a rattle and a slap from the bearings, particularly near the, it sounds to be coming from near the top. If you tighten them up too much, then the bearing overheats and it tends to have a slight squeal to high-pitched noise, sort of a squeal coming from the bearings. If you get it just right, then with the setup I've got, I can run it down to a minimum of 10% of the pulse width scale, and of course up to 100%, which represents about 1400–1500 RPM at 100% speed. So I can just turn the motor on. And that's at 65% speed. And that's flat out. So that's really quite quiet compared to how it was before with the old setup. So I'm quite happy with that. The motor seems to be powerful enough, and that should now work. So I need to do some test machining before too long, and I'm using a pulse width speed controller, and there's just room to tuck it into here, and then have the potentiometer on the front here, the on-off switch and an LED, which is the same as I've got down here for the main spindle, which is a potentiometer, the on-off, and the LED for indicating it's on. So that brings most of the saga of changing the spindle, bearings and the motors over to a completed state, and I've still got a little bit to do on the stepper motor.